Hello, Melody. So, I don't actually have any plans for Halloween yet. I've been thinking about some things, and in the past, I just decided to go ahead and put on a bunch of chainmail. So I've got that, but that's not really. I don't think that's what you had in mind, since I've done that for the past 2, 3-ish years. So I probably should do something a little bit different. Maybe I could go as like a red shirt from Star Trek or something. I've thought about that for a little bit. So I don't know yet. I'll have to think about it, and if I don't come up with something, you'll probably get mad at me, but that's okay. Now, previously, you wanted me to show you something that I mentioned in passing that I thought was pretty cool. So, what it was is a little bit of physics, so if you want, you can actually just like skip past that if you don't care about physics right now. So something really cool you can do. If we have the Earth and the Moon, we know a couple things. We can figure out what the radius is between the center of the Earth and the center of the Moon. That's fine. We can also tell how long it takes the Moon to go around the Earth. And using those two pieces of information, we can actually figure out what the mass of the Earth is. So, the way that we do that, first there's a couple assumptions we have to make. We are assuming that the Moon has a circular orbit, or at the very least we're using an average radius between the two. We're also assuming that the Moon isn't really moving much in its orbit. It's not getting closer to the Earth over time. It's not going farther away from the Earth over time. It's actually not true, but it should be close enough for what we need to do. So what that means is we can assume that the radial force exerted on the Moon is 0, since it's not actually moving any closer or farther away from Earth. So that would mean that we have a force exerted on the Moon by the Earth, that's gravity. And then we actually have another force that is caused by the fact that it's accelerating around a circle, because it's constantly accelerating, otherwise it would just fly off in one direction. And this is centripetal or centrifugal, or it's a made-up force that you feel like when you go around a corner in a turn. And for circular motion, we actually can figure out what that is. That would be equal to the velocity squared over the radius. So using this, we can also use another physics bit, that F is equal to ma, so the force is equal to the mass times the acceleration. In this case, our acceleration is v squared over r. And then we also know the distance that the Moon travels, because we're assuming that the Moon is traveling in a circle. So the distance that it's traveling is just the circumference of the circle, which is 2 pi times the radius squared. Okay, so we have the distance, the time that it takes the Moon to go around the Earth is actually just the lunar month, which is about 27.3 days. So we have the velocity, because we can take that our distance, which is 2 pi r, over just one lunar month, is going to be our velocity. And then you convert that into SI units, but whatever. So we can put all of this together, because we know the sum of the forces is going to be 0, and it's going to be gravity plus our centripetal force is going to equal to 0. So you can go ahead, rearrange this equation a little bit, and eventually you come out with this. Also, you can notice that the mass of the Moon doesn't actually change anything. It cancels out because it's on both sides of the equation. The mass of the Earth is equal to 4 times pi squared times the radius cubed over something called the gravitational constant, and then times the amount of time it takes the Moon to go around the Earth squared. That's how you figure out what the mass of the Earth is when you only know the radius between the Earth and the Moon and the amount of time it takes for the Moon to go around the Earth. next segment, I'm going to cut this out. Alright, so last video I mentioned that I was working on learning Python. And I'm not actually going to use this computer, I'm going to use this laptop. But I made a cool thing that I would like to show you. It is really simple. You are a block and you jump over little green squares. And it's got a random interval as to how often these obstacles will show up. You have points up here, and the blocks will start to get faster as you get more points. Also, you can move left and right. Like this. This took me a few hours. You know what? I'm proud of this stupid little game. It's alright. I mean, it's okay. I might end up turning this into an executable file and then posting this like on my Google Drive and making it public. If in case for some strange reason you want to play it. That way you don't actually have to download Python and also Pygame. Alright, so I'm going to go ahead and die now. Well, after I finish my sentence. I'm going to go ahead and die now because I don't want to go for as long as I possibly can. I also want to show you what happens when you do die. It slows down to default, and it counts your deaths and logs a new high score. It also, it doesn't override that, so that's good. Alright, also, you can no longer double jump while in the air, because like that kind of breaks things. Alright, so that's a little game. And then I'm also currently working on an evolution simulator that I'm building as well. And that's currently a lot of fun. I've got it growing grass at the moment. Well, okay, at the moment it's broken because I'm trying to fix how water spreads, because it spreads fine in one direction and then it just like goes all the way and just fills the entire screen up if you start in the other direction. So that's pretty buggy. I have some ideas as how to fix that, but I'm not actually there yet, so in the future. Alright, so that's what I'm doing now. I'm already going to be editing this down. This is like 17 minutes of recording so far. And mostly it was me talking about physics and programming and showing off a big hunk of metal. Alright, so hopefully I will get this up, probably not tonight, but in the morning. That way I'm technically within the 2 weeks. I kind of procrastinate a little bit on this one, but I'm gonna get it in. Alright, see you, Melody.